That unit is coulomb. Coulomb is the SI unit of charge. And the charge of proton, it is 1.6 into 10 raised to the power minus 19 coulomb. Similarly, charge of an electron is, it is 1.6 into 10 raised to the power minus 19 coulomb. And to represent, it is the value of charge of an electron. It is, we go for using the sign called minus. One student is asking to know about Q is equal to NE. Again, just observe. No doubt it is important. The total number of charge particles present in a body is called the quantity of charge, net charge, resultant charge, absolute charge. So, and this is to be denoted as Q, and it can be found out by using the formula N into E, where N is number of electrons, E is charge of an electron. Here we have written charge of an electron. And another important point, it is then how many electrons charge is equal to 1 coulomb. It is, just recall it, 1 coulomb is equal to, it is 6.25 into 10 raised to the power 18. Once I repeat, 1 coulomb of charge is equal to charge of these many electrons, 6.25 into 10 raised to the power 18 electrons. And charge of 2 coulomb, it is to be written as 12.5 into 10 raised to the power 18 electrons. As it is to be expressed in scientific notation, the value should be here. This part should be less than 10. Hence, it can be written as 1.25 into 10 raised to the power 90 electrons. Both are one and the same. Next, after this, we come across another important term, that is electric current. Just recall the definition of electric current. It is the rate of flow of electric charges. The rate of flow of electric charges is called an electric current. And you also know the meaning of rate of flow of electric charges. It is the number of charged particles passing through any cross section of the conductor in the unit time is the meaning. And the current is denoted by the symbol Q. And the formula that we use to find out electric current is, it is Q by T. I is equal to Q by T is the formula used to find out electric current. This can also be written in another way as I is equal to N into E by T, because Q is nothing but NE. And the unit of electric current, system of international unit of electric current is, it is ampere, A-M-P-E-R-E. And symbolic representation is capital A. The actual unit of electric current is, by using the formula only we have come to know, it is coulomb per second. Coulomb, please do remember, coulomb per second. And symbolic representation is C, S raised to the power minus 1. And when the amount of current is very small, then we will go for using some of the prefixes. Recall those prefixes. They are, one is milliamp, second one is micron amp, third one is nano amp, like this. And you also know the values of these: milli 10 raised to the power minus 3, micron 10 raised to the power minus 6, and nano 10 raised to the power minus 9. Along with that, even we have come to know one more, that is angstrom. Angstrom is, it is 10 raised to the power minus 10, right? Okay. And now one more very important definition which was asked in the examination. Even I had given you that question in your yesterday's worksheet as well. That is to write the definition of 1 ampere of electric current. So 1 ampere of electric current is to be written as 1 coulomb per 1 second. I told you the question can be asked in a different way. If the question is like this, write the SI unit of electric current, you have to write ampere. Or mention the SI unit of electric current, you should write ampere. If they ask you to write the definition of SI unit of electric current, so you have to write the statement like this. The current flowing in the circuit or a conductor is said to be 1 ampere when 1 coulomb of charged particles pass through any cross section of the conductor in 1 second, right? Once I repeat, it's important. When 1 coulomb of charged particles pass through any cross section of the conductor in 1 second, then the current is said to be 1 ampere. The question on this, the question to be asked on this is, define the SI unit of electric current, or define 1 ampere of electric current. So please learn this properly. Okay. Then after that, we come across a device that we use to measure electric current flowing in the conductor or flowing in the circuit. What is that device? It is a meter. A meter is a device used for measuring electric current. A meter is a device used for measuring electric current flowing in the conductor or circuit. When very small amount of current is flowing, so sometimes ammeter is not able to detect that. For detecting, yes, to know whether the current is flowing in the conductor or in the circuit, we go for using another device that is called galvanometer. So galvanometer is a current detecting device. So it detects the current, even very small, very feeble amount of current is flowing in the circuit. So this much was completed in yesterday's class. Now let's move on to, let's continue this part. Regarding ammeter, don't write, just observe. Yesterday only I already written about ammeter, bit information about ammeter. Once you recall, it is a device used for
measuring current.
Device used for measuring electric current.
Electric flow.
Just look at them. You know that the circuit symbol for ammeter, it is like this. You write A and it is to be encircled. On either side, we draw two lines. They represent terminals. One is positive and another one is negative. So we get the ammeter of only which shows in ampere, or the ammeter that shows in milliamps, or the ammeter that shows in micron amps. Yesterday only I had shown you the picture of ammeter. Once I show you, just go through this. So it is ampere ammeter, and this is milliamps ammeter. Milliamps ammeter. And we also know that ammeter, we also know that how ammeter is to be connected in the electric circuit. It should be connected along with the electrical components, that is in series. Ammeter should always be connected in series in the circuit. So there is Reason for that, there are two important reasons. One is ammeter has low electric resistance. That means it will not go for opposing the flow of electrons in the circuit. That is, that opposition is too less. But an ideal ammeter, it offers zero electric resistance, zero opposition for the flow of electrons. Got it? Zero opposition. And second reason is when it is connected in series. If it is connected in series, then there will be no change in the flow of current in the circuit because it will not oppose the flow of current. Clear up? Okay. So this much was, even we had recalled these points as well. Now, along with that, I'll give you another important information. Again, I've been telling you, please not to go for copying. In the ammeter, you can observe the scale, reading scale. It is called scale of ammeter. Here, I'm going to draw that. This is the scale of ammeter to represent that and show the divisions as well. Okay. Yes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like this. It will be continuous. Observe. So here, assume that this is the ammeter which shows or which records the electric current in amps, not milliamps, not microamps. Just I have taken amps. And it is 20, this is 40, and is 60 amps up to here, 80 amps here, 100 amps. Look here, from the current from 0 to 20 amps, could you tell how many divisions are there? 5. There are 5 divisions.
5 divisions, sir.
Okay. Then what is the value of one division?
4 amps, sir.
Very good. 4 amps. See, this is the scale of ammeter. If you find out the value of one division on the scale of ammeter, then it is called least count. Least count of ammeter. Hope you have understood. Once I repeat, the value of one division on the scale of ammeter. The value of one division on the scale of ammeter is called least count. Till I give you the instruction, please don't go for copying anything. Least count is represented, its abbreviated form is LC. Least count. The value of one division on the scale of ammeter is called least count. Then how to find out the least count? Just one of the students said that, sir, the value of one division is 4 amps. How to find it out? It's very simple. Observe. First, you go through the number of divisions. Here, 1, 2, 3, 4, and 5. I have taken up to 20 amps only. So here, 5 divisions is equal to 20 amps. But we want
one division, sir.
One division. So, one division, the value of one division is equal
20
to
by 5.
20 by 5.
20 by 5, sir. 20 by 5. This is equal to 4 amps. Hope that you have understood.
Yes, sir.
So, with respect to this scale, the least count is 4 amps. Least count is 4 amps. Now, let me show you the needle in the ammeter, and you have to tell the reading. Here, so needle now it is showing here.
28, sir.
This is.
28.
Could you tell
28.
the current?
28 amps, sir.
28.
28 amps, sir. Okay. It is 28 amps. Already 20 is there. After 20 years, we have two divisions. One division is 4 amps. Then two divisions, 8. So 20 plus 8, 28. Now let me give you another one. Another reading. This is
72.
72.
72, sir.
72 amps. Hope that you are understanding. So
Yes, sir.
60. Then 1, 2, 3. Third division. First division 4, second division 4, third division 4. 4 plus 4 plus 4, 12. 60 plus 12. It is 72. Now it is 72 amps. Dear students, now I'll show you another ammeter reading. You have to tell the current.
32, sir.
32, sir.
32.
32 amps, sir.
32, sir. 32, sir.
You are telling that 32. No. You do one thing. First, please observe it. Observe
26,
it.
sir.
Wait.
28, sir. 28.
Now it is correct. First, you should find out the least count. What is the least count of this?
23, sir.
26, sir.
26.
26, sir.
Least count is 4, sir.
28, sir.
36, sir. 2, sir. Least count is
24.
2, sir. 2. Least count is 2, sir.
least count is 2.
Enough. Just listen to me. Now I am not asking you the value of current. Just least count. Go through that. Afterwards, just go through. Here, you may take the current from 0 to 20 milliamps. 0 to 20 milliamps. How many divisions are there?
10 divisions are there.
10 divisions.
10 divisions.
Now, look at them. 10 divisions is equal to, it is showing that 20 milliamps. Then one division is equal to 20 by, it is
4, sir.
milliamps. 2 milliamps.
2, sir.
This is the least count of this ammeter. Now you may go for telling the reading.
26, sir.
26, sir.
26 milliamps, sir.
26.
26 milliamps.
26.
After 20, it is in the third division. So 2 plus 2 plus 2, it is 6. It will be 26 milliamps. Followed. Next, another one. First, you tell the least count. Least count of this ammeter.
1.
1, sir.
1, sir.
1,
sir.
1, sir.
1, sir.
Okay, you are right. 10 divisions is equal to 10 amps. 10 divisions.
10, sir.
10 amps.
10 amp.
One division is equal to 10 by 10. It is 1 amp.
1 amp.
Please count. Now, tell the reading.
38, sir.
38, sir.
38.
Very good.
38, sir.
It is 38 amps. 38 amps. Is it clear? Is it clear?
sir.
Okay.
Yes, sir.
Yes, sir.
Again, I'll give you the information. I'll make you to write. Nothing to worry. Just observe the book. Dear students, you have one more information. We all know that when the current is flowing in the circuit or in the conductor, how the electrons will be there. And even before the flow of current also, how will be the electrons? We have come to know in yesterday's class only. Just I make you to recall that. Okay. As in that, this is enlarged part of a conductor. Enlarged part of conductor. is not connected to terminals of a battery, then there will be no flow of current. There is no electric current at all in that. Here, the electrons which are in this conductor will be moving in the random direction. Like this. And if these if the ends of a conductor are connected to terminals of a battery, then electrons will get the energy and they're set to move in particular direction. So now let me show you the direction of movement of electrons. Please observe the book. This is direction of movement of electrons. Look at all are moving from my right side to left side. Right to left. Here, this is the actual movement of the electrons in the circuit when the conductor is connected to terminals of a battery. That is, electrons will flow from negative terminal to positive terminal. Electrons will move from negative terminal to positive terminal of a battery. Do you know what do you call this current? The current in which the actual movement of the electrons, or the circuit in which the actual movement of the electrons is from negative terminal to positive terminal, this is known as, it is called electron current. Electron current. Dear students, even in your previous classes, you have learned that direction of current is to be shown from positive terminal to negative terminal, right? So this is conventionally, we have taken the direction of current from positive terminal to negative terminal, and this is known as conventional current. Then some of you may be thinking that, sir, if the flow of electrons is known, we can also mention the direction of the current from negative to positive. But why do we go for positive to negative? Dear students, I had already given you the information that the concept of electric current was already known before the discovery of electrons. Means the concepts were developed based on the movement of positively charged particles, nothing but protons. So here, the direction of movement of the protons in the circuit, it will be from positive to negative. Hence, the direction of current, don't copy, just observe. Direction of current will be from positive to negative. Actual movement of electrons is from negative to positive, which is called electron current. And conventionally, the direction of current is to be taken from positive to negative. And this is known as conventional current. So these are the two types of currents. So now let me show you the figure related to that. Here I have mentioned. Please observe. Here, this first figure indicates the movement of the electrons when the free ends of the conductor are not connected to terminals of a battery. Next, second figure, the movement of the electrons when the free ends or when the ends of a conductor are connected to terminals of a battery. And third one, observe third one. Here we have mentioned both conventional current, electron current. Electron current, it is nothing but the circuit in which the actual movement of the electrons is from negative terminal to positive terminal. It is electron current. And conventionally, the direction of current is to be taken from positive to negative is known as proton current, nothing but conventional current. Followed? Hope you have understood. Now let me give you some points to be written. Please go for copy. First, regarding ammeter. I think yesterday I had written a statement that ammeter should always be connected in series in the circuit, right?
Yes, sir. Yes, sir.
Okay. And the next point, it is related to least count of ammeter. Right. Least count. Least count of ammeter. Just to recall its definition, it is the value of one division on the scale of ammeter. The value of one division on the scale of ammeter is called its least count. Right, quickly. The value of one division on the scale of ammeter, is called its least count. Can we expect a question from this? Can we expect a question in the examination from this
Yes,
concept?
sir.
Of course, even.
Yes, sir.
Given also. How I'll give you the same how it was given in the examination. Just go for drawing a semicircle and one more semicircle, quick as possible. Next, here 0, here again 1, 2, 3, 4. Sorry, 4. Any number of divisions can be taken. Just 5. Then this is let it be 10. 1, 2, 3, 4, 5. This is 20. 1, 2, 3, 4, 5. 30. 1.
You want to write, sir?
Huh?
You want to write, sir?
You must copy. Scale of ammeter. It is 40. And let us take this is milliampere ammeter. Another one, you have drawn one more semicircle. Please write with me. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're right. 10, 20, 30. In amps. They may ask you the question in two different ways. I'll give you both the ways in these two. Come across the first scale. Hope that you have drawn it.
Sir, division spelling is wrong, sir.
D-I-V-I-S-I-O-N. Okay, very good point. The first sub question is, what is the least count of first ammeter?
2, sir.
Very good. 2 kilometer, centimeter, liter.
Milliamps.
Very good. It is milliamps. Right. You just go for finding it out. We know that five divisions will represent 10 milliamps. All right. 5 divisions is equal to 10 milliamps. 10 milliamps. Then one division is equal to 10 by 5. The value of one division is nothing but
2 milliamps.
2 milliamps. And just below that only, you have to write reading answer. They may ask you, write the current that is shown in the ammeter. What is the current that shows?
18, sir.
Okay, it is in the 4th division. Up to here 10, then 12. Because we know that least count is 2 milliamps. One division value is 2 milliamps. Here 10, 12, 40, 60, 80. Did you understand?
Yes, sir.
Okay. And below this you write I is equal to 18 milliamps. I is equal to 18 milliamps. Next, come across second one.
Sir, repeat first one, sir.
Count.
Sir, repeat first
1
one, sir.
amp, sir. 1 amp.
Very good. Very good.
Sir, repeat first one, sir.
First one. The value of one division is least count. Here, 5 divisions will represent 10 milliamps. We have written that. One division is 10 by 5. This is 2 milliamps. And the reading is in this division, fourth division after this 10 milliamps. So 2 plus 2 plus 2 plus 2, 8. 10 plus 8, 18. 18 milliamps. The second one, let us find out the least count. Here, 10 divisions.
1 amp, sir.
Is equal to
1 amps.
10 amps, not 1 amp. 10 amps. Then one division is equal to 10 by 10, which is nothing but 1 amp. So 1 amp is the least count. Least count of second ammeter is 1 amp. Next. Now you tell the reading. Only to make it visible clearly, so that just
14 amps, sir. 14 amps.
14, sir.
You are right. See, up to here 10, then 1, 2, 3, 4. Here also fourth division. 1 plus 1 plus 1 plus 1. 4. 10 plus 4. 14 amps, not milliamps. It is amps. Right. I is equal, below this, I is equal to 14 amps. I equal to 14 amps. Hope that this concept is clear to you.
Sir, why not milliamp?
Here it is milliamp. The reason is in the ammeter only it is to be mentioned. When you are going to find out when the current flowing in the conductor is small, then we will go for using milliamps. If more, we'll just go for using ampere or ammeter. Next, right. Types of current. Types of current. Write it quickly. One is electron current. Electron current. Please go on writing with me. Don't be lagging. Electron current. Second one is conventional current. Conventional current. Electron current and conventional current. So let us show that with the circuit. Yes, draw. Take scale and pencil quickly. Here. First, let me show you the enlarged part of the conductor. This is enlarged part of the conductor. Then connect the free ends to the terminals of a battery. Connect the
Sir,
free
we
ends
should draw, sir.
to the
Sir, we
terminals
should draw.
of a battery.
Sir, we should draw, sir.
And this is positive terminal. You know that longer line represents positive terminal.
Sir, we should draw like this.
You must draw negative terminal, positive, negative, positive, and then negative. If you want, you can write, mention the switch as well. Assume that the switch is on. Now show the direction of flow of electrons. Here, just I'll take few electrons. First one, this is second one, third one, fourth, fifth, sixth. When you switch on, then electrons start flowing from negative terminal to positive terminal. Please show the direction of flow of current, flow of electrons properly. This is direction of flow of electrons, and we call it as electron current. Electron current. Next, another one. Conventionally, the direction of current is to be taken from positive to negative. And this is called proton current, is nothing but conventional current. P. Kaleshwar, it is conventional current. Conventional current. Hope that you have copied. Now just let me go for taking two simple numerical problems which have been given in the textbook. Right, side heading, numerical problems.
Raghavendra R, Karan Kumar M, are you writing or watching only? Huh? Write it down. Don't sit simply.
Please do follow the instruction. Okay. And if you go on writing with me, it will be easier. You have to move a little bit quickly. So you have to write with me. Okay, copy. Very good. Now, please write the side heading. Numerical problems. Numerical problems. Right. First one. First one is from the textbook. Right. This is a current now. A current of 0.5 amps is drawn by a filament. By a filament of an electric bulb. Electric bulb for 10 minutes. For 10 minutes. Full stop. Find the amount of electric charge. Find the amount of electric charge. The amount of electric charge that flows through the circuit.
Nihal Adimani, write it down.
Flows.
Nihal Adimani, write it down. Write down the question. Okay.
Flows through the circuit. See, hope that you have copied. And one thing you must remember, this year, whatever the physics concepts you are going to learn, in many times you come across mathematics. Both physics and mathematics are interrelated. See, here also, we have some statements. Very good. Just look at them. Once you go through the given statement, see, a current of 0.5 amps. 0.5 amps is drawn by a filament of an electric bulb. Dear students, just recall the filament that is used in electric bulb.
Tungsten, Guruji.
Tungsten, sir.
Good. You are
Tungsten.
right. It is tungsten. Tungsten is the filament that is used in electric bulb. What is the reason for using tungsten?
Sir, it has high melting point.
High melting point. High melting.
One is it has high melting point. Then it has high electric resistance. Just only for recalling purpose, I told. By a filament of an electric bulb for 10 minutes. That is, the filament used in an electric bulb will draw the current of 0.5 amps in 10 minutes. If so, then find the amount of electric charge that flows through the circuit. Means in every cross section of the conductor, what charge will flow, that should be calculated. Dear students, when you are attempting any physics related problems, you have to understand the statement properly and you have to write the given information. Let us write that in right data. Please write with me. Could you tell what does 0.5 amps indicate?
I, sir.
It is very good. Current is I. I is equal to 0.5 amps. You may also write it as 1/2 amps. It is current is already in SI unit. Next, by a filament of an electric bulb for 10 minutes. What does 10 minutes indicate?
Time. In seconds,
Time.
600 seconds. 600 seconds.
Wait. No. You have to answer to my question. I am asking you, what does 10 minutes indicate?
Time.
Time.
All T is equal to 10 minutes. Another very important thing that is to be noticed is whenever we are using the terms, whatever the physical quantities we are going to use, their units must be same. That is in the same form, either CGS or FPS or else SI. That is System of International Unit. Usually we follow System of International Unit. Okay, current is ampere, it is there. But SI unit of time is
Seconds.
Second.
sir.
So you must convert to seconds. It is equal to 10 into, we all know that 1 minute is equal to 60 seconds. Right.
600.
Then this is equal to 60 tens of 600 seconds. Now, please go through the statement. Find the amount of electric charge.
Q, we need
What is
to
the
find
symbol used to represent the amount of electric charge?
Q. Quantity of charge.
Yes. Capital Q. Right. Capital Q equal to question mark. Capital Q equal to question mark. Prem P. Kaleshwar. Calculation. Observe. Please observe. Don't try. You know I know that you are good in writing, but when the teacher is explaining, without missing any information, you have to listen. Here, I, P, and Q. These are the three terms. Could you tell in which formula we can
I
come
equal to
across
Q by T, sir.
Q by T.
That is current formula. I is equal to Q by T. I equal to Q by T. We want Q. You may go for solving
Q is equal to IT.
Q is equal to I.
Q is equal to NE.
Don't tell in between. You have to. I expect your response after my question. Q is equal to I into T, where I is 0.5 amp and T time is 600 seconds, and this is equal. You may
300.
multiply it directly.
300, sir.
And you know that 0.5 can be written as 1/2 into 600. Cancel it. You will get
300, sir.
300, sir.
Coulomb.
very good. It is Coulomb. You must write the unit without fail. Q is equal to 300 C, nothing but
Coulomb.
300 Coulomb. If you do not mention the unit, half marks will be cut off in the examination. Please do remember, without fail, you have to mention the unit. If they expect the calculation like this, it will be asked for 2 marks. If they expect the direct answer, it will be given for 1 mark. Okay, next, I'll go for taking 1 more. Then afterwards, we'll move on to the next concept.
Sir, repeat it, sir. Calculation part, repeat it, sir.
Calculate this part. I is equal to Q by T. We want Q. Just go for cross multiply. It becomes I into T, where I is 0.5 amps and T is 600 seconds. 0.5 can be written as it is 1 by 2. 0.5 is 5 by 10. 5 by 10 is 1 by 2 into 600. Cancelling. 2 ones are 2 300s. So therefore, the quantity of charge is 300 Coulomb. Next, second one. Calculate the current in the circuit. Calculate the current in the circuit. Calculate the current in the circuit if 500 Coulomb of charge pass through the conductor in again they are given 10 minutes. As I have already understood how to go for calculation, now this time try yourself. Meanwhile, you can also write here. You are going to calculate the current in the circuit. That is I equal to question mark. If 500 Coulomb of charge,
0.8.
500 Coulomb indicates quantity of charge. Q is equal to next of charge passed through the conductor in 10 minutes.
600 seconds.
It is time. T is equal to 10 minutes. 1 minute is 60 seconds. Then 10 minutes will be 600 seconds. I'm writing it directly. Very good. Vishnu, you are right. Calculation. We know that I is equal to Q by T. We want I, you write this as it is, where Q is 500 and T is 600. 0, 0 get cancelled. You'll get 5 by 6. 5 by 6 is, it is 0.833. 8 sir.
333, sir.
It will be 0. It will be 15.
0.833.
833, sir.
6 8s are 48. 2 will remain 20.
33, sir.
6 3s are you will get recurring decimal part. It's equal to, approximately it can be written as 0.83 amps. Even if it is written in the fraction form, it's okay, no problem at all. I is equal to 0.83 amps. It can, one student is asking that, should it be converted into decimal? If it is terminating, you can go for that. If non-terminating or recurring, you may keep that as it is, or else you may extend this. Hope that you have copied. Now we are moving to the next concept of this chapter. Okay. Just to recall the definition of current. It is the rate of flow of electric charges. Yesterday, some students were asking that, sir, we have come to know about the charges, but how these charge particles are responsible for representing electric current? How, if we have told that it is, current is nothing but flow of electrons, flow of charge particles. If the charge particles will flow, from where do they get energy? If they are getting the energy, how much energy they have? So these are the questions raised by you. It's very good. Now in this session, let's go for answering all of these. And before going to introduce those concepts, I'll take one simple example. Assume that this is the ground. Here is a stone. A little bit big stone is there. You have to push it. What should be done? So work has to be done on that. Nothing but you have to apply the force. But do you know what amount of force is to be applied?
More than the stone.
If you want to come to know that, you have to exert force on that. So first you will assume that you will apply 1 Newton of force, but it will not displace. Then you will go for increasing. So as the amount of force used to displace the stone increases, then can we say that its potential is more, or its energy?
Yes,
Energy with which it is on the ground is more. Got it?
yes, sir.
One student is telling,
Yes,
as we
sir.
are exerting the force more and more amount, we can say that its potential, it has attained the position tightly.
Yes, sir.
Similarly, even for if you want to know how the charge particles will move in the conductor, you must know their potential, and we call that potential as potential energy. Followed?
Yes, sir.
Yes, sir. Yes, sir.
And as this potential
Yes, sir.
energy is related to the charge particles, and this is known as electric potential. Now let me make you to understand what is that electric potential. Observe. Don't go for copying anything. Just look at them. Here, this is the conductor. And I am going to take just enlarge part of the conductor. In that, so many charge particles will be there. I am going to take just one charge particle. And we do not know what is its potential, like weight in case of stone, right? As the force increases, we can understand that it has more and more weight. Similarly, here, if we want to make it to move, nothing but if it is to be displayed, then it has some energy. We are going to find out that energy. To find out that energy, another charge particles has to be brought nearby it. So that is why we will go for connecting the free ends of the conductor to the terminals of a battery. Now, there is another charge which is somewhere else in this circuit. And this charge particle, it is somewhere else, means it is at infinite. It is at infinite place. So if it is to be brought nearby it, some work has to be done. So this work done in bringing this unit positive charge from infinity to the given point in the electric field. And we call it as electric potential. Did you understand?
Yes, sir.
Huh?
Can you repeat, sir?
I want the right response. I want the prompt response. Once
Yes, sir.
Just observe.
No, sir. Repeat again, sir.
If it is okay. Definitely. Just observe it. Here is a store. It is to be displaced. To displace that work has to be done. To do that work, somebody has to apply the force. Now assume this store as a charge particle. This is the charge particle. Then here, whatever the work has to be done by the application of force, it is another charge which is to be brought nearby it. You all may be thinking that, sir, why should we go for bringing that charge? We know that when like charges are brought each other, they repel each other. When they repel each other, even when the unlike charge is also brought each other, they attract each other. In both the cases, anyhow, the displacement will take place. Got it? So here, similarly, to displace this, to know its potential, another charge has to be brought. But where is that charge? We do not know. It is somewhere else in the conductor. So whatever the work has to be done in bringing this unit positive charge from infinity to the given point. To bring this charge from infinity to this, so we have used the battery. Battery means here somebody is applying the force on the stone to displace it. Here that somebody is the battery. So here the unit positive charge is to be brought from infinity to the given point in the electric field. And whatever the work has to be done in bringing so, it is called electric potential. Once I repeat, listen carefully. Don't go for copying. The work done in bringing a unit positive charge from infinity to the given point in an electric field is known as electric potential. Did you understand? Any doubt?
No, sir.
No, sir.
No, sir.
No, sir.
Okay. You have doubt, but you are not telling. I'll tell you that. You have no doubt. You have understood this. You may be thinking that why should we go for taking unit positive charge only? Is it not? Dear students, earlier only I told you that the concept of electricity was developed based on the positively charged particle, because in that time electrons were not discovered. And again, based on that only we are going to take this. The work done in bringing a unit positive charge from infinity to the given point in an electric field. Got it? Any more doubt?
No, sir.
No. Yes or no?
No, sir.
No.
No, sir.
No, sir.
Here, I used one more word. You're not asking that. I told that the work done in bringing a unit positive charge from infinity to the given point in an electric field. Then what is an electric field? It's a new word for you, right? What is an electric field? Listen. Here, if I go for taking the charge, around this charge, there will be a field. And we call this field as electric field. Got it? The region around the charge where the electrostatic force is present is known as electric field. So next, this to find out the electric potential of the charge, we go for using two physical quantities. Could you tell what are those? One is the amount of work has to be done in bringing some quantity of charge. So it depends on two physical quantities. One is work done, second one is quantity of charge. Hence, the formula that we can use to find out electric potential of a charge is V is equal to
W divided by
Q. Followed? Where V is electric potential, W is work done, Q is quantity of charge. And this electric potential is also a measurable quantity, nothing but physical quantity. It can be measured by using the unit that is called, anybody?
volt.
It is
Voltmeter.
Not voltmeter. It is volt. Volt is the system of international unit of electric potential. First, we have to understand. Afterwards, I'll give you the points to write. Electric potential. I told you the definition, then formula and the unit. Okay. Now, let's move on to another concept. Here, just look at it. Here is the charge. We know that there is a current in the circuit, which means the charge particles are moving. Here, just we have come to know only the potential of the charge, but still it has to move. Now you have come to know that its potential is about 5 volts. Its potential is about 5 volts. If it has to move continuously, there must be difference in its potential. Is it not? So first 5 volt is there, then it has to change its potential from 5 volt to some other volts, maybe 7 volts, 8 volts, 10 volts like this. Clear up? So we assume that it has displaced and it has attained the potential of about 7 volts. What is the difference in their voltage or potential?
2 volt.
2 volts. And we this as potential difference. Dear students, I know that still you need a clarification. Now I am going to give you that clarification. Dear students, just imagine a horizontal pipe. A pipe is taken, you have kept it horizontally and pour some amount of water in that. That pipe is like this. It is water in that. Whether when you hold that horizontally, whether water flows in that?
No, sir.
No, it will be stagnant, right? Now I'll go for taking just another simple activity. Look here, I have taken 2 bottles. 2 bottles. Assume that water bottles. One is named as A and another one is named as B. And first we have made just a hole, hole with a distance of 3 centimeters from the bottom of each bottle. Then a small pipe is connected. And assume that you'll close this by using a clip in this place. Next, you'll go for taking the amount of water in both the bottles, A and B. Got it? Here, the level of water taken in A is more than that of level of water taken in B. Now my question is, if you go for removing the clip here, whether water flows or not?
Flow, sir.
Flows, sir.
No, sir.
Where to where? Whether it flows from
A to B.
or B to A?
A to B, sir.
A to B.
A to B, sir. A to B, sir.
A to B.
A to B, sir.
The reason?
A to B.
Because A is having more water than the B, sir.
More amount of water. No, anybody can tell that. Even first or second standard students can also tell that, sir, water will flow from bottle A to bottle B because the level of water in bottle A is more than that of B. But how this level of water is responsible for making the water to flow
Diffusion.
from
Diffusion, sir.
Diffusion,
sir.
It exerts more pressure, sir, on the
biology
wall.
concept. It's all chemistry concept. Okay. Just observe here. Here, the potential of water in the bottle A is more. So, therefore, water flow from higher region to lower region. Here, higher level, high potential to, or the amount of water that we have taken in A is more. Very good. Therefore, pressure is more. As more amount of pressure is there in A, water flows from A to B. So, in this, we can say that water flows from high pressure to low pressure. Similarly, electrons will flow from electron-rich region to the electron-deficit region. Don't copy, just look here. Here, could you tell how long the water flows from A to B?
Till it will become
Until
Until it will become equal. They're both equal.
Wait. No. I'm not asking you when the flow of water stops. I'm asking you how long the water flows from A to B. As long as there is difference in the level of water in A and B, till then the water flows. If the level of water in A and B is same, so there will be no flow of water because pressure will be same. If the water has to flow, there must be difference in the pressure. Similarly, if the electric charges should flow, there must be difference in the potential of the electric charges. Did you understand?
Yes, sir.
To create that difference, again, the work has to be done. So work has to be done in moving a charged particle from one region to another region in an electric field is called potential difference. Understood? Did you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Work is done in moving. Work is, if you want to find out the difference, there must the charge particle should move. So if they are to be moved, there must be, their work has to be done. So the work done in moving the charge particle from one point to another point in an electric field is called potential difference. So this is another term, potential difference. Very important one. And this potential difference is abbreviated as PD. And this is also known as, you are very familiar with the word called low voltage, high voltage. Is it not?
Yes, sir.
The word voltage is another word used for potential difference. Potential difference is nothing but voltage. Voltage, clear up? Now, here also, see that once you recall the definition, work has to be done. Work has to be done in moving the charge particle from one point to another point in an electric field. Here also, potential difference depends on two physical quantities. Could you tell what is that? It depends on two physical quantities.
Electrons and protons.
Again, Same only. Work has to be done in moving charged particles, in moving some quantity of charged particles. So it also depends on, it depends on W as well as quantity of charge. Therefore, potential difference can be written as work done by time taken. Work done by quantity of charge. And potential difference is also denoted by capital V. Then work done is denoted by W. Quantity of charge is denoted by Q. V is equal to W by Q. In your textbook, you might have noticed that they have given the words electric potential and potential difference, but much information is not there. I have given you that. Please use it. Don't copy, I'll give you time. Here, V is equal to W by Q. You have to focus on this concept for the examination point. V is equal to W by Q is the formula used to find out voltage or potential difference. Next, it's SI unit.
Volt.
System of international unit of voltage or potential difference is
Volt.
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 is volt, denoted as
Volt, sir.
V. And the word volt has been taken from the name of a scientist.
Alessandro Volta.
Alessandro Volta.
Very good. Alessandro Volta. Look here. And the other unit is to be taken
Joule.
from the formula. Observe here.
Joule Coulomb.
Joule per coulomb. Joule per coulomb.
Now, question ಕೇಳಿದಾಗ ನೀವು answer ಮಾಡಿ. It will be easy for following by others as well. SI unit of work done is joule.
Joules.
SI unit of quantity of charge.
Coulomb.
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 Coulomb. Then what is the actual unit or other unit of potential difference?
Joule per Coulomb.
Joule per coulomb.
Coulomb. Joule per Coulomb. Did you understand?
Sir.
And
Yes,
simple representation J C raised to the power -1. Now we have to define 1 volt. 1 volt. This 1 volt can be written as
1 joule by 1 coulomb.
1 coulomb. Now let me tell you the definition. Listen carefully. The potential difference between the ends of a conductor is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of charged particles from one point to another point in an electric field. Just like a definition of potential difference. Clear? Once I repeat, listen carefully. If I ask you to write the SI unit of potential difference, you may write volt. If I ask you to write the definition of 1 volt, it should be written like this. If 1 joule of work is done in moving 1 coulomb of charged particles from one point to another point in an electric field, then the potential difference is said to be 1 volt. Then you all may be thinking that how to maintain that potential difference, how to maintain this pressure difference to make the water to flow continuously from A to B. How to do that?
We should make another hole in B.
Let me tell you that. Observe here. Here, if you want to make the water to flow from A to B continuously, you illondu water motor iruttala adanna fix maadu. You just connect the pipe from A to B and fix a pump here. It will lift the water from again B to A. Then water flows from A to B like this. Understood? Are you following?
Yes, sir.
Same way, Illi kuda aste. If you want to maintain, if the charge particles have to move continuously, there must be constant potential difference. To maintain that constant potential difference, we will go for using battery. Electric battery. In that battery, due to the chemical reaction takes place, so it will maintain the difference in the potential of charge particles. With that difference, the charge particles will move continuously. And we call this battery as a source of EMF. A source of EMF. I'm using the abbreviation EMF. You know what it is? It is electromotive force. See how very simple to understand. Here, electrons are there. They are to be made to move continuously. They must be motivated. Means they have to get the energy. That energy is obtained from this battery or cell. This is electromotive force. Now, let me tell you what is electromotive force. It is the energy given by the battery to maintain the constant potential difference across the ends of the conductor. The minimum energy required to maintain the constant potential difference across the ends of the conductor is known as electromotive force. And here, whatever the cell we are going to use, whatever the battery we are going to use, generator we are going to use, they are all the sources of EMF. Sources of electric cell, electric battery, and so on. Did you understand?
Yes, sir.
Nothing to worry. First, you have to understand the concept. Dear students, now we have come across three important terms. One is electric potential. Second one is
Potential difference.
Difference.
Electromotive force. So you just go for telling the definition of these in your mind along with me. Electric potential, the work done in bringing a unit positive charge from infinity to the given point in an electric field is called electric potential. Potential difference, the work done in moving charge particle from one point to another point in an electric field is called potential difference. The energy required to maintain the constant potential difference between the ends of a conductor is known as electromotive force. Understood? So these three terms will constitute electric current. Andre current iga flow ಆಗ್ತಿದೆ circuit ಅಲ್ಲಿ ಅಂದ್ರೆ it is understood that there is potential difference, and this potential difference is provided by
EMF.
Source of EMF. Got it? Do you expect electric current in the conductor without connecting it to wire? Sorry, without connecting it to battery?
No, sir.
No, sir.
Battery irrelevant. If there is battery or if there is cell, then it gives the potential difference. With that potential difference, the charge particles will move continuously, which constitute electric current. Clear? Now I'm going to give you the definition. Please write with me. Write the side heading. Important terms. Side heading. Important terms. Right. Side heading. Important terms. In that first one, electric potential. Important terms. That first one is electric potential. Electric potential. Write the definition. It is the work done. The work done in bringing a unit positive charge. A unit positive charge from infinity to the given point. To the given point in an electric field. In an electric field is called electric potential. Electric potential. Enough. Then write formula. This is electric potential. Electric potential is equal to work done by charge. Work done by charge. And electric potential is denoted by V, work done is denoted by W, and charge is denoted by Q. V equal to W by Q. Then below that, write SI unit. It is volt in bracket, write V. Should write this much only. Next. Potential difference. Potential difference. Right, second one. Potential difference. Right. In bracket, you just write P. And we also know that it is also called, what is the other name?
Voltage.
Voltage. Right. Write the definition. The work done in moving a charged particle from one point to another point in an electric field. Is called potential difference, and is very important definition. Please put 3-star mark. Is called potential difference. And you know the definition of electric field. It is the region around a charged particle where the electrostatic force is present. Just do remember that. Write the formula. It is same only. That is potential difference, PD, is equal to work done by charge, quantity of charge. Potential difference is denoted by capital V. Work done is denoted by capital W. Quantity of charge is denoted by capital Q. Then write. Could you tell what is the other way we can write the formula of potential difference?
Joule per coulomb.
Q.
W by NE.
Very good.
V is equal to W by NE.
You are right. Very good. Now write SI unit. SI unit is, it is volt. SI unit is volt. In bracket write V to represent it. Another unit is, what is the other unit?
Joule per
Joule
coulomb.
per coulomb.
Joule per coulomb.
Very good. Joule per coulomb. Joule per coulomb. In bracket, you can write C, S raised to the power minus. Right, Anna? Next, put 3-star mark. 3-star mark and write the definition of 1 voltage or 1 volt. Potential difference of 1 volt. Write its definition. If 1 joule of work is done, if 1 joule of work is done, if 1 joule of work is done in moving, yes, what we should be written? What we should write?
Quantity of charge.
Quantity of work.
If 1 joule of work is done in moving,
A quantity of charge.
very good.
Coulomb.
Pratham Raikar, you are right.
1 coulomb.
In moving, 1 coulomb of charge from one point to another point in an electric field. From one point to another point in an electric field. Then potential difference is said to be said to be 1 volt. The potential difference is said to be 1 volt.
Sir, SI unit, you have written a coulomb per second, sir.
Huh? Joule per coulomb. J C raised to the power minus 1. Please correct this one. Oh. Written up. Gautami, have you written? Okay. Now, you know this. Right. 1 voltage is equal to 1 voltage is equal to
1 coulomb.
1
Joule by 1 coulomb.
1 joule per 1 coulomb. 1 joule per 1 coulomb. Written up. Over. Listen. Dear students, you just observe here. Could you tell what it is?
Battery.
It is an electric cell.
Battery cell.
Also called dry cell. It is an electric cell. And I'll tell you its voltage, actual voltage. Before that, think that its voltage is 1 volt, which means that it can do 1 joule of work in moving
9 voltage.
of charged particles.
1 coulomb.
Got it? Are you understanding?
Yes, sir.
Are you understanding?
Yes, sir.
Sir.
So that's the meaning.
Sir.
It is.
Sir, what is the difference between battery and cell, sir?
Sir, here, in case of battery, we will go for taking more than 1 cells. That is a battery. Okay, once I tell you, if its voltage is 1 volt, then it is understood that it can do 1 joule of work in carrying or in in moving 1 coulomb of charged particles from one point to another point. Got it? Okay. Okay. Dear students, next another important term is, it is electromotive force. Third one. Electromotive force. In bracket you may write EMF. EMF. Just write the definition. It is the energy required to maintain the constant potential difference. Across the ends of a conductor is called EMF. Just below, sources of EMF are, just I'll give you 2 examples. One is electric cell and another one is battery. Written up. Yes, students, still we have to get more information about this, particularly potential difference. Maybe the device used to measure potential difference and the important properties of that device. Along with that, some other important concepts are there. So let us go for learning these concepts in tomorrow's class. Okay. So shall I conclude the class?
Sir, 1 minute.
1 minute, sir.
Meanwhile, just listen. So whatever the important definitions we have learned today, please do practice them today itself without fail. And evening I'll give you the worksheet, some important questions in the worksheet, and please solve them without fail. And even I'm very happy to share one thing, that yesterday 97% of the students have submitted their worksheet. Please keep going in the same consistency. And still few more are there. I request other students who have not yet submitting regularly, please submit, at least from today. Okay, I'll conclude the class. So with this, let us stop the class. Thank you very much.
Thank you,
Have a great day.
Thank you, sir.